Alright, here's your example, B4C. Now go ahead and try and figure out what the name of this compound would be. Alright, if you don't already have your answer, just go ahead and pause the video and write it down for yourself. Now, boron is the first element, and there are 4 of them. So, you go over here, tetra is 4. Remember, a good way to remember that tetra is 4, Tetris. That's how they got the name for Tetris, is because each single one of the blocks that you move around have 4 mini blocks that make them up. So, Tetris, tetra, 4. So it would be tetra, boron. Now, there's one quick reminder why boron is first in this compound. If you look at the electronegativity, again, I don't know if you can see this, but it is in the upper right-hand corner right there. And the other one we have is carbon right there. It's a smaller of the 2 numbers. That is the one which goes first. Now, how many carbons are there for this next one? Oh, there's 1. 1 is mono. So you write, after tetraboron, you write mono carbon. Oh, excuse me. I almost forgot. It's carbide, not carbon. You'd write carbide because you need the "ide" ending. Tetraboron monocarbide. That is your compound. And that is how you name binary covalent compounds. One more thing before I close this section out. You may be wondering, wait, in the last one he showed us how to write the formulas. Why didn't he do it on this one? Well, the reason for this is the same reason why on the formulas you never reduce subscripts for covalent compounds. It's because, for example, N and O, well, there are 6 different types of compounds that have just N and O in them. So there's no way to tell what the formula will be just by looking at the periodic table. What you have to do is look at the name, and you can figure out what the formula would be. I'll show you real quick to make sure you understand it. Tetraboron monocarbide used to do the exact same thing as what we've been doing previously. Tetra is 4, that means boron would have a 4, and mono is 1, so carbon would just be 1. Alright, the next topic is polyatomic ions. Now, a polyatomic ion is a charged group of covalently bonded atoms. It is multiple atoms that are covalently bonded together, meaning they are all non-metals. Example would be CO3 negative 2. See, it's the negative 2 shows that it is a charge, it's not neutral, and there are 2 atoms, a carbon and an oxygen. Because it has an O3, I guess that'd be 4 atoms that are covalently bonded together. Now, when you're naming and using these polyatomic ions, you treat that ion like it is 1 atom. You don't treat the carbon and oxygen separate. You treat them like they are 1 atom. All the polyatomic ions we'll be talking about will come off this polyatomic ion sheet. So how do you name these polyatomic ions, especially when they're bonded to different elements? Well, it's very simple. You just take the name of the first atom plus the name of the polyatomic ion. and you leave this name of the polyatomic ion as is. You don't change it. So if you look closely on the sheet, just one I would find iodate. You would write iodate. Hydrogen sulfate. You would write hydrogen sulfite. You don't have to change the ending at all. So, just a couple of examples. Alright, so here are a couple of quick examples. MgSO3. How would you name this? Well, you'd first look at the first atom, Mg. That is magnesium, so you'd write magnesium. Oops. Sorry about that. And then you write the name of the polyatomic ion. SO3, according to this polyatomic ion sheet, it's right here. That is sulfite. Right there, sulfite. Magnesium sulfite. That's the name. Pretty simple. It's not that hard to do or remember. Now go on to this next one, NaBrO2. Well, Na, we know, is sodium. Then BrO2, well, go back to your polyatomic ion sheet and look for BrO2. It's right here. That is bromide. The name of this compound would be sodium bromide. Alright, I'm going to clear this board and then write a couple of quick examples for you to try on your own. Alright, here's the first example for how to write the proper formulas for polyatomic ions. I'll be explaining as I go with this. The first step, what you have to do is look at copper 2. You just take, excuse me. Alright, the first step to writing formulas of polyatomic ions is look at the first part, copper. Write the symbol for copper, which I believe is Cu. I'll just check on the periodic table real quick. Copper is, in fact, Cu. Then, you go on the polyatomic ion sheet, and you see what the formula is for sulfate. Sulfate is right there. SO4. But after this step, you are not done. You have to take into account the charges of copper 2 and sulfate. Copper 2, we already know the charge because it has a 2 right there. So copper would be positive 2 because of that 2 after. Sulfate, go back on the sheet and look. Oh, sulfate is negative 2. So you write negative 2 after the sulfate. Then, similarly, similar to ionic compounds, you do the crisscross method. Cu2 SO4 2. Then you can cancel out with polyatomic ions. You can reduce these subscripts. 2 and 2, that reduces to 1 and 1. So the formula is CuSO4. Alright, this final example I'll have you try and do on your own. It is sodium sulfate. Okay, if you have not figured it out by now, which I doubt you have, didn't give you very long, just pause the video and take your time to try and figure it out. But I'm going to go ahead and go over the answer. First, find the symbol for sodium, which is Na. Then, find the formula for sulfate, which after looking on my sheet, I see is SO4. I'll just put parentheses around it now to help keep it straight. Then you go and you find the charge for sodium. Sodium, if you're looking on the periodic table, it's in this far left column. So it has a charge of +1 because it wants to lose that 1 electron to become like a noble gas. SO4, sulfate, after looking on the sheet, right here, has a charge of -2. I don't know if you can see that real well. See if I can get you a better view. There. Sulfate is SO4, it's -2. Put the -2 there. You do the crisscross method. Na, 2 goes to the Na. And then the SO4 takes the 1. But because it's just 1, you don't need to write it. So that is a symbol for sodium sulfate.